A certain compound contains lead, carbon, and hydrogen. If it only contains 64.07% lead by mass, and if there are 2 carbon atoms present for every 5 hydrogen atoms, what's the empirical formula? Okay, so this is kind of a tricky, just the wording is kind of tricky. So I want you to learn how to see problems where the wording is tricky. So let's just say that we've got a compound with lead, right, and carbon and hydrogen. Okay? And it tells us that we don't know, it says, what's the empirical formula? So we don't know the ratio, but we do know something about carbon and hydrogen. It says that there are 2 carbons for every 5 hydrogens. What we don't know then is how many lead atoms there are. So you need to be able to read problems like this and go, what's my X? What is it I'm looking for? In some of the previous problems, we were given X, we were given the number, and we were not sure what the element was. In this case, we know the element, so we know its molar mass, but we don't know X. Our X, this case, is how many there are. What's the mole ratio? All right? I'm going to simplify this a little bit. I'm gonna treat this as one element, and if I do that, I combine the whole thing, it's going to simplify the problem. I'm going to assume 100 grams. That allows this to be treated as 64.07 grams. So now I know the lead is 64.07. If I subtract that from 100, I'm going to get my mass of, whoops, where'd we go? Of C2H5. That's what I'm going to figure out first. So I'm going to start with 100 grams of the compound. That's an exact number. And I'm going to subtract 64.07 grams of lead. Okay, and that's going to give me 35.93 grams of C2H5. So that's gonna be a big help here. Now I can figure out what is the mole ratio of C2H5 to lead, because I know everything about them. I know their molar mass. So I'm going to start. I could start off. I want to end up with a mole ratio. I could start off with lead on top, or I could start off with C2H5 on top. One will give me a whole number, and one will give me a fraction or decimal. I'm going to start off the harder way, which is going to give me, I already know the answer, it's going to give me a fraction. So 64.07 grams of lead to 35.93 grams of C2H5. Now hopefully you see why we're treating C2H5 as if it were one element. It's just going to simplify the whole thing. We could have used carbon or hydrogen, but this simplifies it. So I'm going to do this as one thing. All right, so I'm going to change both of these to moles. I'm going to change this bit of the molecule to moles. That's 29.04 grams C2H5. So we just looked that up on the periodic table, added up per mole, C2H5. And then I want to change lead to moles. So 1 mole of lead is 207.2 grams of lead. All right, so now my mole ratio, if it works out to 0.25, that'll be the answer. Now, what does that mean? That means, and if we cancel everything out, we'll see. Those grams cancel and these grams cancel, but moles don't. So the units would be moles Pb per mole C2H5. And I'm just going to put a 1 here so we can see our ratio is 0.25 to 1. Now, what does that mean? Well, if I try to write it as a formula, we would see that x equals 0.25. Well, that's not going to be the answer. Maybe you already know what to do. And then C2H5, that gets a 1. So now I need to remember my multipliers, that if I have a 0.25, what do I multiply by? This whole thing, in order to make this a whole number. Well, if I multiply that whole thing by 4, that gives me lead as 1. 4 times 0.24 is 1. And then C2H5 would be times 4. It's not really 1 unit, so I'm going to take 4 times 2. That gives me C8. And 4 times 5 gives me H20. And so that is the formula of my compound.